All right, I'm going to try this a little bit differently. I'm not going to use the document camera. I'm going to use this screen capture thing, so we'll see if it works a little bit better. But what we're going to look at right now are exponential functions. And exponential functions you looked at back in Math 1, but we're going to look at them again and see if we can just review what they are and how they work. So far, we've really analyzed linear functions, which look like this, y equals mx plus b. Right? And then last chapter, we looked at quadratics in detail, which was y equals ax squared plus bx plus c. Now we're going to look at these exponentials. And the one that we're going to look at to start is y equals, we're just going to have a b to the x. And we're going to look at a couple of these and see if we can graph them and see how they work, and then try and play around with some of those graphs. So the first one that I'm going to look at, using some graph paper here, is y equals 2 to the x power. So if I want to graph this, I'm going to start off with just my t-table here so I can get a feeling for what this looks like. I'm going to go with a -2, -1, 0, 1, 2, 3, just so I can kind of see what this graph is going to look like. Make my table so I can look at my function. Now, plugging in numbers for an exponent, it brings in a lot of things that you may have forgotten about things like exponent rules, so we're going to review those too. If I want to look at plugging in a 1, I've got 2 to the 1 power, which is just 2. If I plug in a 2, I've got 2 squared, which is 4. I've got 2 cubed if I plug in a 3, which gives me 8, and you'll notice that this is getting really big really fast. And then we have to remember what is anything to the 0th power. We have to remember that anything to the 0 power is 1. Anytime that we raise it to the 0 power, we've got 1 for the output. Then we're going to get up here to these stinky little negative exponents. And we have to remember, what does a negative exponent do? And we have to remember that a negative exponent flips it to the bottom of a fraction. So this is going to be 1/2. And then 2 to the -2, that's going to be a 1 over 2 squared, which is a 1/4. So if I graph this real quick, we're going to see what happens and see what is important about this graph. So graphing my nice points first, 0, 1, 1, 2, 3, 4, and then if I plug in a 3, I get a 4, 5, 6, 7, 8. I'm busy, honey.
Mom.
What? 1/2?
Get me a brown.
1/4?
My brown's like almost tasty.
Okay. Well, can I get you some more chalk here in a few minutes? Give me a little bit, okay? Go use other colors for now. So I'm going to connect my dots, and you'll notice what happens here. It gets steeper and steeper this way. If I was to plug in my next one, it would be 2 to the 4th, which is 16. So there's 8, 9, 10, 11, 12, 13, 14, 15. Oh, I can just barely fit it on my paper. It's right there at the very top. Right, so it gets steeper, faster, and faster. On this side, it's going to keep getting shallower and shallower. And this is where we have to think about, honey, it's going to be a little bit, okay? We have to think about what's going to happen right here. Here is what we call an asymptote. I feel like I spelled that wrong. I feel like there's a Y in there, but I don't have my paper with me. Asymptote. Think something like that. I'm not sure. But you guys know that you come to me for math and not for spelling. Anyways, the idea of the asymptote is that it gets closer and closer and closer. Guys, sorry. We're having a rough moment. Hopefully I can cut this out. Okay, so it gets closer and closer to the x-axis here, but it will never touch it. And if we think about what we're doing to get those numbers, I can plug in bigger and bigger negative numbers in here. I could plug in a negative 100 and it's going to be 1 over 2 to the 100. A very, very tiny number, but it will never actually be 0. It just gets closer and closer to it. So we can do the same thing with maybe, because you'll see them both with f of x and in that y form. So let's look at 1/3 to the x power and see what happens with that. I'm going to make my table. And so I've got x and f of x this time. And I'm going to plug in those same values just so that I can see what happens. So if I plug in a 1/3, or sorry, a 0, 1/3 to the 0 power, that's always going to be my easiest one. It's just a 1. And then if I plug in 1/3 to the 1 power, remember that my exponent applies to both of them. It still is just going to be 1/3. If I've got 1/3 squared, that's going to be the top is squared and the bottom is squared. So that's going to be a 1 over 9. And then this one's going to be a 1 over 27 because I have to square or cube the top and cube the bottom. Going the other direction, if I've got 1/3 to the 1/2 or to the negative 1, that's going to flip it. It flips it back up and it just becomes a big 3. If I've got 1/3 to the negative 2, it's going to flip that 3 up to the top, right? Flip it up there and it's going to square it, so then it's going to be a 9. So if I look at this, I've got 0, 1. I'm going to do my big numbers. These ones actually come back this way. 1, 2, 3. And then 4, 5, 6, 7, 8, 9. And then 1/3, 1/9, 1/27. So this one is very similar to the other one, except for it's going the other direction. And we'll notice that that base was a fraction. And it also is steeper than the one up above. Here, let me show you. See, this one here is pretty steep. This one here, it's a little bit steeper. So let's go ahead. I'm going to switch over to Desmos, which is why I'm doing this the way that I am, so that we can kind of look and see what happens with our b to the x. If we look right here, I'm going to zoom in my whole thing here. This right here is where I've got my b to the x. So this is my function. B is going to be my slider. So right now b is 1, and if you'll notice, it's a straight line. And if we think about it, 1 to the x power, it's always going to be a straight line. But as I make this steeper, as I have it be a 2, notice it's pretty steep. But as this number gets bigger, now it's a 3, 4, there we go, there's 4. Let me zoom out and kind of here. All the way up to 10. All that it does is it changes that rate so that it gets steeper and steeper and steeper. Now if I come back down here to, well, we don't want to be at 0. I want to be back here at 1. I'm going to change this because we have to have that b can only be between 0 and we'll say it can go up to 10 again. It can't be less than 0. We don't have a negative inside of our exponential function. But notice what happens is as I'm between 0 and 1. I end up with it flipping this other way, right? Because if I'm over here, I have these whole numbers that are being raised, or at least larger than 1, and they're being raised to an exponent. So they're getting bigger and bigger and bigger. But here I have something that is less than 1. Like if I look at, say, 0.5, right? This is something that is less than 1, and it's raised to an exponent. As I'm raising it to those positive exponents, it's getting smaller and smaller and smaller. It's like I'm finding what's 1/2 of 1/2, what's 1/2 of 1/4, what's 1/2 of 1/8, and so on. And it gets smaller and smaller. The negative exponents are those ones that flip it, making it get bigger and bigger. So that's something important to pay attention to. The other thing to look at is graphing form. So graphing form is going to be y equals a times b to the x, or not just an x power, actually, hold on. A times b to the x minus h, and then it's going to be plus k. Okay, so these, and actually instead of a b, oh, I've already got my b up there. So let's just say that I've got b is going to be a 2. So if I'm looking at that, all of those are 1, but if I bring it back to 0, right? If I have a 0 in here, that means that this is just a to the 1 power or to the x power, and that this is not adding anything. But as soon as I look at my k, remember k is that vertical shift. Notice it's just moving it up and down my y-axis. It's just changing where that y-intercept is. It's also changing where my asymptote is. Whatever that value is, if k is 3.7, then that's where my line is going to go to. Notice that this is up 1, 2, 3, and then it goes up to 0.7. So wherever that is, that k is going to tell you where my horizontal asymptote is. I'm going to put that back at 0. Oh, maybe. There we go. If I'm looking at h, remember h is that horizontal shift. Right? If I set h over here to 10, notice that instead of having a y-intercept here at 10, I've got it way over here. I'm going to change the color of this one. That would probably help a lot, huh? Maybe. Edit. Change my color to purple. Done. Okay. Now you can see that one moving back and forth. So if I have my h is going to be -5, right? Notice that I'm back here at -5. If I'm up here at a +5, notice that it's almost like my y-intercept is just shifted over. Now this multiplier, it works just like the multiplier does with my my quadratics, right? When I was looking at multiplying it by 2, that just made it steeper. If I was multiplying it by something that was less than 2, it made it less steep, right? This is making it less steep. As soon as it went negative, it flipped it down. Right? If I'm multiplying it by something that's negative, it's going to flip it upside down. Okay? So hopefully this will be enough to get you ready to graph quadratics. The problems that you're going to be looking at are 66 through 94 are just asking you to graph. You can make a table if you'd like. That would probably be helpful to get a feeling for these. And then 110 to 114, they're going to be looking at using those transformations. Okay, so I will have another video for how to solve these exponential equations and then looking at some of those applications as well. So I hope to talk to you soon. Adios.